Hi everyone, welcome to our grade 12 math session. My name is Vaitseba, and just to make sure that everyone is in the right session, this is grade 12 math session. Okay, and we're still doing differential calculus. So please note down my email address. It's my name and no spaces, name and surname at gmail.com. Okay, so these are some of the links that I use. So I use the Siafula textbook for grade 12. You can use any other textbook, still the same content. And in every chapter, we're just going to try to go through our DBE past papers so that we can practice for our exams. Okay. So if you use a different textbook, still the same content, so don't worry about that. Okay. So, and again, if it's your first time joining us today, or you just wanna have a preview of the sessions from the other days, you can go to our Africa Teen Geeks website, or you can just go directly to our YouTube channel, the Africa Teen Geeks YouTube channel, search for your grade and also your subject. So there's other subjects, not just maths. So you have other subjects that you can also go through the sessions from the previous week. Okay. So, and then you can also check out our Facebook, Twitter, and Instagram pages for updates. For example, motivational sessions and on Wednesdays. I think there's also one today from VET. So just be on the lookout for career and motivational sessions on our website. But then still, if you miss them, you can still go to our YouTube channel just to get an update. Okay. So during the lesson, just make sure that you're on mute and your videos are off. And we'll have questions after an example or exercise. Or you can send me an email after the lesson. And we only have maths related questions in our chat. Okay. So just make sure that if you try to ask questions, you are more than welcome to send me an email. In today's session, we are going to learn how to draw cubic functions, and we're gonna use the knowledge we have of finding a derivative to draw that function, and other knowledge for factorizing cubic function. So we're just gonna draw a cubic function today. So from yesterday's homework, you will notice that you were given two equations of the form ax cubed plus bx squared plus cx plus d. Okay, so you were given two equations of this form, and what you will notice is that the value of a was different. So I just wanted you to have an idea of what a equation looks like. Okay, so if you tried the homework, you will notice that when your a is greater than 0, your function will look something like this. Okay, and then if your A, remember this is your A, so if your A is less than 0, then your function will have this shape. Okay, so the homework was just for you to see the different shapes when changing A. Okay, so another thing that you should note is that with regards to our cubic functions, our turning points, we also name them as stationary points. Okay, so you will still have your x-intercept as usual, y-intercept, and then you will have your stationary point, which we also name our local minimum and our local maximum. Okay. So I just wanted you to see the shape. So when we draw a cubic function, the first thing we will do is to check the sign of A, which will determine the shape of the graph. Okay, so we'll check A to know the general shape of the graph. Okay, and then we will determine our y-intercept by, I hope you still remember that when we want to find our y-intercept, we let our x equals to 0, isn't it? So if you want a y-intercept, your x equals to 0. Okay. And then if you want to determine your x-intercept, what happens? Your y equals to 0. So when you do your x-intercept, your y equals to 0. So this is just a general overview of our function would look like. But then remember, when you're solving for x, for a cubic function, please revise how to use long division, inspection, and all that. So you will need to revise how to factorize this. So you need to revise how to factorize a function, a cubic function. Okay, so the one thing you will note is that maths is just a chain of rules. So you learn something in grade 8 and then they add something new in grade 11, but you still use concepts from grade 10. And then same with grade 12, you still use all the concepts from grade 1. Okay, so it's just a build up of concepts which are all interlinked together. And then the interesting thing is that to find our turning points, we can use what? Our first derivative. Okay, so remember the prime means first derivative. If it's double prime, then it's the second derivative. So to determine the coordinates of our turning points or our stationary points, we'll calculate the derivative and then let the derivative equal to 0, then solve for x. So you see where we apply our knowledge of derivatives. Okay. And then to determine the y coordinates of the turning points, so you would have solved for x. So to determine the y coordinates of the turning points, you will substitute your value of x. So the value that you get here after finding the derivative, you will substitute it into the original equation. Please note that. So you substitute it in the original equation, not in this equation, in the original equation. So you will substitute it back into this equation that you are given. And then you will show all your points and then draw your graph. Okay, so let's go through an example. So in this case, we are given a function. Okay, so we're given a function, a cubic function, and we are supposed to sketch the graph. Okay, so we still use the procedure from previously. First, we need to determine the shape of the graph. So it means we need to write our equation. So b x squared. Okay, so we have to write our function in the general form so that we can remember to determine the shape of the graph. To determine the shape, you need what? You need the value of a. Remember, so you need to check if your value of a is greater or less than 0. Okay, so if you write your function in this form of a plus bx squared plus c, you can see that your value of a is what? So your value of a in this case, so which is this one? Okay, so there's a 1 here. So I was saying you need to show that it's in this form so that you can identify your a. Okay? So now you can see that, oh, my a is actually what? So a is equals to 1. Okay, so you just write the general form so that you can identify your coefficients in the equation. But then if you can do it, you don't need to write down the equation. Okay, so a is equal to 1. And this means our a is greater than 0. Okay, so we look at the shape. Remember from the previous slide, we saw that, oh, if a is greater than, then this is the shape of our graph. Then you show that as your answer. Okay, so the shape of your graph will be in this form. Do we all understand this part? So the A is just to show you the shape of the graph. So if your A was negative, then you would have the shape being the other way. So now that we have identified the shape of our graph, then we can determine the intercepts. Remember, we can determine our y-intercept by saying x equals to 0. And then our x-intercept by letting our function equal to 0. Okay. So in the first case, remember, we're still using our original equation. Okay. So we substitute in the place of x, we substitute 0. Okay. And then we'll solve for g. So this means when x is 0, y is 0. Remember, this is your x coordinate. So this is your x, and this is your y. Okay. And then from there, you need to find your x-intercept. Now you let your function equals to 0 and solve for x. Okay. So this one was a bit easier. So you could just say, oh, okay, now it's 0. And then you let, remember, if you look at all the terms, you have x. So you can make your x a common factor. And then you remain with x squared minus 3x minus 4. To check if what you wrote here is correct, you simply just check, okay, what is x times x squared? It is x cubed. To make sure that your signs are correct. Okay, so what is positive x times negative 3x? So it's negative 3x squared. And then you check the last term, what is x times negative 4? So now this is correct. Okay. And then after that, you do what? You factorize. Remember, if you can't easily factorize by inspection, then you need to use your quadratic function. Okay, but then in this case, it was easy to solve by inspection. And then, but then in other cases, you might have to use your quadratic function. Okay, so then you show that your x equals to -1 or 4, and don't forget this one to show that x is equals to 0. So it means your intercepts, you have how many x-intercepts? You have 3. So in all the intercepts, your y value is 0. And then you have the other corresponding x values. Okay, so do you guys understand up to this point? No, it will depend. Okay, Cheslin is asking if we will always have 3 intercepts. No, it will depend on your function that is given. Okay, so that's why you need to check. So it will depend on the equation of your function. Okay. So Cheslin, okay, great. So remember, guys, you need to calculate your intercepts to check how many intercepts you have. The number of intercepts is dependent on the function that you are given. Okay. So can I move to the next step? Okay. You still have a question, we'll come back to it. And then now, remember we said to find the x coordinates of our stationary points, which is our turning point, we find g prime or the derivative of the function, and then we equate that to 0. Okay. So in our case, like I said, there will be cases where you can't factorize easily, like in this case. Okay, so you find the derivative of your original function. So this is the derivative of your original function. So this is the derivative of your original function, okay? And then you say your derivative equals to 0. Then what do? Then you solve for x. If you can't easily find your factors by inspection, then you use the quadratic formula. Okay. So remember our quadratic formula is also A square plus B x plus C. Okay. So our A in this case, so our A is 3. Our B is -6. Very important. Our B is -6, not +6. It's -6. Okay. And our C is -4. If you substitute +6 and +4, your answer will not be correct. So it's very important to make sure that your signs are correct. Okay. Okay. I think before I move on, let me, I think Chislin has a question. Chislin?
Ma'am?
Yes, you are asking.
How come 4 is not equated to 0, ma'am? Because isn't it a constant? It doesn't have a variable or anything.
Okay, let's go back to. Let's go back to our original function.
Okay, ma'am.
Okay. Remember, from the original function, we have 4x. So,
Oh, okay.
yeah. So
Sorry, ma'am.
remember, x is raised to the power of 1. So this is 1. So you will only have 4.
Okay.
Is
Thank you,
that
ma'am.
right? Okay, great. Okay. So after finding our derivative, just make sure that you understand how we got the derivative. If you still need help with that, then you can ask me. Okay. So remember, always label your A, B, and C correctly. If you don't label your A, B, and C correctly, your factors will not be correct. Okay. And then you substitute into your quadratic formula, and then you find your x values at your turning point. Remember, after you find your x values, you go back to the original function, not the derivative, original function. So let me highlight this. So your x into your g of x. So the original function, not this one, the original function. Okay, so you substitute your x values into your original function to get the corresponding value of x. Okay, and then you finally show your points. Okay. So, Kyle is asking if you can be asked to work the other way backwards. Hey, so it is possible. It's just, yeah, you could try it because already you know that your exponent is 1 less. So if you add 1 to your exponent, then you already know what your coefficient was. Okay. So then now you have your x coordinates that from finding derivative, which is when you're looking for your stationary points or your points. So stationary points or turning points. Okay. Then now you have your points. So you have your turning point, you have your x and y intercept. Okay. So you can easily plot your graph. Okay. So you will have your 3x intercept, you will have your y-intercept as 0, 0, and then plot your graph because you have your turning points and you know the shape because you know your value of A. Okay, so today I just wanted you guys to see how we draw and then you can go and try it. And just wanted to remind you that if you were to factorize something like this, because it's part of your question. So to factorize this term, usually the first factor we find by trial and error, isn't it? So you substitute 1 and see what you get. Okay, so if your answer is not 0, so if you substitute 1 into this equation and you don't get 0, then it means your x minus 1 is not a factor. Okay, so that simply means that positive 1 is not a root of this function. Okay, so and then you'll have to try a different value. So usually if you tried 1, you'll try negative 1. Okay, so you would substitute negative 1, and because you have 0, okay, then it means x, so negative 1 is a root to the function. Okay, so you will need to revise this, guys. So if you substitute negative 1, your answer is 0, then it means x plus 1. So x plus 1 is a factor. Okay, so because when you substitute it into your original function, you get 0. Okay, and then after you find your first factor, because it shows you that you either use inspection, because remember you would have had, so after you find your first factor, So after you find your first factor, so you would have something like x plus 1 multiplied by something. Okay, so you know that you need to multiply x plus 1 with something to give you this term. Okay, so either by inspection or long division. I always find long division easier, but you will find a method that works for you. Okay, so either by inspection, so you will try either try by inspection or long division, okay, to get this term after you found your factor. Okay, and to check if what you have on the other side is correct, you will have to multiply this by this. And then if it gives you the original equation, then it means you're fine. Okay. And then what you also notice is that you also need to factorize x squared minus 9. Okay. So remember, this is what? Difference between two squares. Like we have it here. So this is different, but it won't always be difference between two squares. But then you know a lot of methods for factorizing quadratic functions. So if it's not difference between two squares, you use either the quadratic equation or any other method that works for you. Okay. And then that would be the case. So just revise all of this and then, yeah, you'll be fine. So we're just connecting everything we've learned. Okay, so now questions. Okay, Jadida. Wait, Jadida.
Hi, ma'am.
Yes, you were asking if it's always easier. The thing is, maybe now because you haven't done it often, you think maybe it will take long. But you can even see by inspection, like you can do the trial and error from the top of your head once you do a lot of problems. But it's always easier with trial and error. But you can also try other methods. You can look into the chapter where you factorize polynomials, and then you see the method that works better. But the trial and error one is usually better. Because what I usually do, to find my first factor, I use trial and error. And then after I find my first factor, I use long division. Because sometimes I struggle with inspection. But then someone else would do trial and error and then do inspection. So whichever method works for you, then you will use that one.
Okay, thank you, ma'am.
Yeah. Okay, just revise factorizing cubic functions and then you decide a method that is simpler for you. Okay. There's a question.